You ever stumble upon a word that seems to hold an entire puzzle inside it? Well, today we're cracking one of those open. It's a single word that, believe it or not, connects ancient Greek philosophy to the most advanced artificial intelligence we have today. And that word is ontology. So yeah, how on earth does one word end up with two definitions that seem worlds apart? On one hand, you've got these deep, fundamental questions about existence itself, and on the other, it's about making computers smarter. It feels like a total mix-up, right? But stick with me, because you're about to see how these two worlds aren't just connected, they're actually merging. All right, to figure this out, we've got to go way back. We're starting with the original thinkers who first tried to wrap their heads around the nature of reality. So, in philosophy, ontology is all about the big stuff. It's trying to understand what existence is. It's not just looking at a specific thing, like a chair or a star, but at the very structure of reality that allows those things to exist at all. It's the ultimate quest to define what's real. Now, fast forward to the 20th century, and a philosopher named Martin Heidegger comes along with this just game-changing idea. He said, look, we don't really understand objects by making a list of their properties. No, we understand them by what we do with them. We get them through their purpose. Heidegger uses a hammer to explain this, and it's brilliant. When you're using a hammer to hit a nail, you're not thinking, this object weighs 16 ounces and has a wooden handle. It's just part of the action, right? It's an extension of your arm. He called this being available. But the moment that hammer breaks, or you just see it sitting on a table, everything changes. Now you see it as an occurrent object, a thing with specific physical traits. And that leads to this really key idea he called the ontological difference. It's the gap between the concept of a thing, its purpose, its being, and the actual physical thing itself, the entity. Now, tuck that idea away, because it's going to pop up again in a very unexpected place. Okay, let's hit the fast forward button and jump from deep philosophy to a super practical, very modern problem, the absolute chaos of our digital world. Think about it. Every single industry, medicine, banking, shipping, you name it, has built its own digital language, its own way of organizing information. And the problem is, these systems don't speak the same language. A hospital database and a bank system might both use the word account, but they mean completely different things. This is the huge headache known as semantic interoperability. And man, this is a tough one to solve. I mean, how would you even start to categorize everything in the world in a way that everybody agrees on? It's kind of impossible. Our own languages are super ambiguous, and every expert field just goes and creates its own little data island that doesn't connect to anything else. So, faced with this digital Tower of Babel, computer scientists needed some kind of universal translator. They needed a blueprint for meaning itself. And this is where our other kind of ontology enters the scene. In the computer world, an upper ontology is like a master dictionary. It doesn't define every little thing, but it defines the most basic, universal concepts out there. Words like object, process, relation. It's a shared foundation that everyone can build on top of. And this isn't just some theory. There are real projects doing this. You've got basic formal ontology, or BFO, which is huge in science for making sure data from different labs can actually be compared. Then there's Sumo, which is one of the biggest ones out there, used all over the place in AI research. They're creating that common ground. So if the upper ontology is the dictionary, you can think of the web ontology language, or OWL, which is a great name, as the grammar. It's the official, standardized language we use to write these blueprints for knowledge in a way that a machine can actually read, understand, and even think with. And OWL has this one feature that is just genius. See, most databases work on a closed world assumption. That means if a piece of information isn't in the database, the system assumes it's false. Full stop. But OWL works on an open world assumption. If something isn't stated, it's not false. It's just unknown. And that is so much more like how we actually experience the world, isn't it? Our knowledge is never complete. Okay, so we have philosophical ontology, which is about the nature of reality, and we have computational ontology, which is about organizing data for machines. It's time to finally connect these two dots. So here's the bridge. If we want to build a truly intelligent AI, it can't just be a number cruncher. It needs to understand the world. And to do that, it needs a kind of conceptual map of reality, what things are, how they're related, what they're for. And the job of building that map, well, that's basically a philosophical project. You're defining existence for a machine. And hey, remember Heidegger's hammer? This is where it all comes full circle. For an AI to be genuinely useful, it has to understand a hammer not just as a collection of data points and a current object, but as an available tool for hammering. It has to get the context, the purpose, its whole reason for being a tool. So really, these computational ontologies are the foundation for modern AI. They give the AI the framework it needs to reason, to understand relationships, instead of just memorizing facts. And that open-world assumption lets it deal with the messy, incomplete information of the real world, just like we have to. It's what separates a fancy calculator from something that can actually think. And that brings us to one last, really big question. As we build machines that don't just compute, but actually understand the world, we are literally programming a version of reality into them. We have to choose how to slice up the world into concepts. So the question isn't just, what does it mean to be anymore? It's, what are we going to teach our machines it means to be? And that's a question with consequences we're only just starting to grapple with.